In industrial pipelines, pressure drops, leakage, and premature valve failure are constant threats to continuous operation. When a component fails to regulate severe operating conditions, you lose system stability and invite catastrophic downtime. You can eliminate these failures before the hardware is even manufactured by building a complete, error-free technical specification sheet for your valve orders. Step 1 is gathering your exact system prerequisites. Before looking at hardware, you need to define your fluid type, your operating temperature, and your system's maximum pressure limits. Translating those basic operating conditions into precise technical specifications ensures you procure equipment capable of securing your infrastructure for the long term. Now we determine the exact function required. The mechanical motion inside a valve dictates exactly how it controls fluid, making different designs suited for very specific tasks. This animated diagram compares a linear motion globe valve on the left with a straight-through gate valve on the right. Notice how the globe valve moves a plug vertically against a fixed seat, granting precise throttling control. The gate valve simply lifts out of the way, making it strictly for full on or off isolation. Comparing the globe valve to this quarter-turn ball valve on the far right, you can see the ball valve is built for fast shutoff. It lacks the internal geometry necessary for the high-accuracy regulation the globe valve provides. You must, however, avoid the slurry trap. Because of its internal structure, a globe valve has a high risk of clogging and failing if deployed in systems carrying viscous or solid heavy fluids. Specifying a globe valve is a commitment to precise flow regulation. You accept a higher natural pressure drop to achieve absolute control over the pipeline. Step 2 is selecting the correct body pattern. The internal shape of the valve body forces the fluid to change direction, which directly impacts your pressure drop. This fluid dynamics animation illustrates the standard T-pattern globe valve. The fluid takes an indirect, sharp Z-shaped turn through the body. This geometry guarantees excellent throttling accuracy, but generates the highest pressure loss in the system. Changing to a Y-pattern design creates a much more streamlined flow path. This visibly reduces turbulence and cuts energy loss, which makes it the correct choice for higher pressure systems. If your piping requires directional changes, an angle pattern combines the valve and an elbow fitting to save space. For highly toxic chemical systems, you specify a Bellows seal design, adding an accordion-like metal barrier over the stem to ensure zero external leakage. Failing to match this internal pattern to your pipeline's specific pressure tolerances creates unnecessary resistance and degrades the energy efficiency of the entire system. Step 3 is selecting your structural materials. This matrix chart aligns common fluid types with exact industrial-grade metallurgical materials. For standard water and marine applications, you assign bronze materials, typically covering pressure classes from 125 to 300. General utility fluids pair well with iron, but as soon as you transition to demanding applications like fuel oil or boiler cooling systems, you must specify cast steel, which secures classes from 150 up to 1500. Extreme high-pressure systems up to class 2680 require forged steel. For corrosive chemicals, stainless steel is mandatory. Do not purchase entry-level materials for demanding systems. Putting a cast iron valve on a high-pressure steam line guarantees rapid erosion and premature failure. Strict alignment between the fluid type, pressure class, and physical material is the only reliable way to guarantee the life cycle durability of your equipment. Step 4 is procurement. A perfect technical specification on paper is useless unless you partner with a manufacturer capable of actually executing the build. This supplier evaluation checklist details a definitive 4-point criteria. First, verify their industry certifications to confirm compliance. Second, demand comprehensive testing reports to ensure quality control before anything ships. Third, confirm their customization capabilities. A capable supplier can alter internal trim designs, utilizing anti-cavitation or low-noise seats to handle your exact pressure drops. Finally, verify their deep industry experience. You need a partner that provides practical engineering support and problem-solving, rather than a middleman processing a transaction. Manufacturers like Valverno in China are structured to meet this rigorous 4-point standard, offering consistent quality and technical guidance. Executing this strict vetting process guarantees that your theoretical design sheet translates into a physical, reliable infrastructural asset. By following these 4 steps, you have successfully built a bulletproof technical specification. This document shows what a fully optimized request for quote looks like in practice. It establishes the control function, demands a Y-pattern body, specifies stainless steel at class 1500, and requires a custom trim. As you submit your quote to manufacturers, prioritize total life cycle cost over the initial purchase price. A properly specified valve minimizes downtime and saves capital over the long run. To finalize your engineering specs and confidently begin procurement, download our technical PDF guide below.